Let's make this happen. We have 16-2 today and 15-1. So let's start with 15-1. 15-1 is pretty easy. Getting that done. Okay, let's mute all of y'all.
You're gonna see nothing interesting.
There we go. There we go. All right. So first things first, 15-1 is about factoring polynomials. You have to make sure that you understand how to do numbers by themselves. You have to be able to do numbers by themselves. Then you have to be able to do variables by themselves. Now, the way we explain factoring is opposite of what? Distributing. Okay? And we spent plenty of time with distributing. So if I had 3, x plus 3, we know that when we distribute, arrows mean what? They mean multiplication, multiply, right? So guess what? Factoring, you're going to do what? That's right. You're going to divide. You're going to divide something out called what? GCF. What's a GCF? Greatest common factor. All right. So, greatest common factor, let's get into it. The greatest GCF, common factor, when dealing with numbers, is the biggest number that will go into 2 or more numbers. So, what do I mean? Let's pick some even numbers because they're easy. All right. So, let's say 12 and 16. Immediately, you know that 2 will go into both. But what I want you to do is reshape the way you think. First thing you should do is look at the 12 and the 16 and see if they go into each other. Now, 12 does not evenly go into 16. 16 does not evenly go into 12. And that's when you start dealing with a factor tree. Okay? So factor tree is not a factor list. Factor trees start with prime numbers. So 1 does not count. So we start with 2. 2 times what? 6. 6 is even, so I can do 2 times 3. So the factors of 12 are 2 times 2 times 3. 16, start with a prime number, 2. 2 times what? 8. 8 is even, so I know I can go another 2. 2 times 4. Oh, 4 is even, so I can do another 2. So 16 is 2 times 2 times 2 times 2. These are all the factors of 12 and 16. What we want to do is not duplicate any of these. So if I circle this one, I need to circle the same one on the right side. If I circle this 2, that means I need to circle another one on that side. And I can only pull out one of them. So when I say one of them, I have 2 blues, I can only pull out 1. I got 2 greens, I can only pull out 1. So the biggest number that I can get out of 12 and 16 is going to be 4. So yes, long way, you probably would have known that as you go through, but it makes big difference when I start throwing in 120 versus 242. Now you're not exactly sure what that is, so you have to factor it, get the prime factors, and then group them together. We're not going to do this. I just want to let you know that that is the method by which you would get the numbers. So let's talk about the variables. Variables to me are even simpler because I don't have to keep figuring out what's what. Let's say I have x to the 5th and x to the 3rd. What does that really mean? First, I need to know, are they the same variable? Yes, they are. So now, x to the 5th means x times x times x times x times x. And x to the 3rd means x times x times x. That's what that means. So you do the same thing. I got a pair there, I got a pair there, and I got a pair there. So how many of those x's can I pull out? You guessed it, 3. So this is how simple this is. If I have the same variable, look at the one with the smallest power. I know that there's at least 3 on the left side too. So I can pull out x to the third. That's how simple that is. Okay? So let's stop there for a second because I want to make sure that concept is understood. Is that concept understood for numbers and for variables?
Indeed.
Yes,
Yes.
sir.
Pretty
Yes,
simple
sir.
and straightforward, correct?
Mm-hmm.
Okay. All right. So let's make this happen. Let's make it a little bit harder.
You're gonna get out of.
All right. So now, let's say we have a combo. I have 4xy. Let's put a squared on that. And let's compare it to 8xy squared. How do I do this? Well, the first things first, always deal with the numbers first. So let's deal with the numbers. So now I'm talking about trying to find the GCF. So I want to compare what? 4 and 8. Now, I could do the factor tree and everything else, but what did I tell you to do first? Look at the numbers. Do they divide evenly into each other? Well, 4 divides into 4. And I know that 4 divides into 8. This is 1, this is 2. So therefore, 4 is going to be my GCF. Pretty simple. Now, I look at x. I have an x on the left side. I have 2 of them. I have 1 on the right side. Which one's the smallest one? The 1. So I know there's at least one x on that left side. So I can pull out an x. Now I look at what? The y's. I have a y and a y squared. So I have one y over here. I have 2 y's over there. I have 1 is the least amount. So I know there's at least 1 on that right-hand side. So I can pull out 1 y. Therefore, my GCF is this whole thing, 4xy. That means 4 times x times y. And how can I prove that? Divide it in. So here we go. That was my fault. Hit on the button. All right. So now 4x squared divided by y. So now 4xy. Correct? This is my GCF. Since that is my GCF, when I divide, I need to get an even number. And when I say an even, a whole number. I shouldn't say even. A whole number. So 4 divided by 4, 1. X squared divided by x to the first power. That means x, 2 minus 1. I get x. Y divided by y is what? 1. So therefore, 1 times x times 1 is just x. That's complete. That works. So now, 8x y squared divided by our 4xy. 8 divided by 4 is 2. X divided by x is 1. Y squared divided by y to the first power really says what? Oh boy, here we go again. Don't you just love technology? So here we go. 8xy squared divided by 4xy. We said that was 2. That was 1. And y there is y squared minus 1. So I get y 1. So that really simplifies to just what? 2y. It's a whole number, correct? So I'm good to go. So I know I think my hands are greasy. I had an egg sandwich. So here we go. With that being said, it divided in evenly and it was a whole number, okay? So let's go over here, spread this out, let that zoom in. And I'm gonna bring in Alexander. Can you hear me?
Yeah.
Good.
Yeah.
So let's deal with this first problem.
Oh. All right.
So we got 15 and 35. So how do I find the GCF of 15 and 35?
5.
It's going to be 5. Does 15 go into 35?
No.
Does 15 go into 35? No. So we have to factor it. And when we factor it, we find that 5 is the biggest number that goes into 15 and 35, correct?
Yes.
Awesome. What about x to the 4th and x squared?
I forgot.
Which one has the smallest power?
Oh, 35x squared.
Do I care about the 35 now? Didn't we already deal with the numbers?
Wait, what? Or may you repeat that?
Didn't we already deal with the numbers? We know that the
Oh,
GCF is 5.
yes.
So I'm
Yes.
only looking at the x's, right?
Yes.
Which one has the smallest power?
35x squared.
Okay. So you're saying the 2, correct?
Yes.
So that means there's at least 2 x's on that side, correct?
Correct.
So therefore, I can just write 5x squared.
Wait. Hold on. Sorry. May you repeat that?
So all I have to say is my GCF is 5x squared, correct?
Yes.
Beautiful. All right. Let's go to Brianna. Let's deal with this -6 and 9. What is your GCF?
3.
3. Good. Now you could have chose -3 because -3 would have went in 2. But for the most part, right now, let's just keep it even. Okay.
Mm-hmm.
All right. Let's look at the T's. How many T's are on the left side?
4. 1.
How many T's are
The
on the
four.
left side?
4.
What problem are you looking at?
I don't know. Hold on.
We're right here.
There's 3. 3.
Yeah, 3. How many T's are on the right side?
1.
1. So how many T's can I pull out?
You can pull out 3. Right? You can pull out 1.
Thank you.
I'm confused. I'm sorry.
All right. If I have 3 T's on the left, I have 1 T on the right. How many pairs can you create on the right and left? I have 1 here. I have 1 here. Are there any more left on the right-hand side to make a pair?
No.
No. So how many pairs can you pull out?
1.
1. So why not just look at the smallest power and pull that out?
Okay.
Does that make sense?
Mm-hmm.
All right. Carlos.
Yes.
There you go, my man. Let's look at number 5.
It should be 2.
Let's look at 12 and 12.
Yeah.
So what number can I pull out?
2.
I can pull out a 2, but is that the greatest number that I can pull out?
Oh, the greatest one, 6.
Is that the greatest?
Yeah, that's the biggest.
Can I pull out a 12?
Yeah.
So isn't 12 bigger than 6?
Oh, yeah, it is.
So I can pull out a 12.
Okay.
Are there any A's on this side, on the right side?
No, nor B's.
Or B's. So can I pull out an A or a B?
Nope.
No. So the only thing I can pull out is a 12, correct?
Yeah.
Great job. There we go.
Eat.
Everybody, with that being said, you would be able to do 2, 4, and 6, correct?
Mm-hmm.
All right. So let's move on to the next one.
Precisely.
DeAndre,
What up, Moonshine?
factor each polynomial. So here we go. If we're going to factor each polynomial, I know you were here the last time I did this. We put parentheses around everything. Then we make a blank set of parentheses that is the same width, correct?
Yeah.
What do we put on the outside?
The GCF.
The GCF, correct?
Yeah.
So remember, factoring means what? What are we going to do? What math operation?
I divide.
There you go. I knew you could read. So here we go. What can we pull out when it comes to 8 and a 7? Is there anything I can pull out between 8 and 7?
No.
No. So now let's look at the C's. Can I pull out anything from the C's?
Yes.
Yes. How many C's on the left?
2.
How many C's on the right?
1.
How many can I pull out?
Uno.
Uno. So now I'm going to rewrite this so you can see this. Remember, we put parentheses. Then we copy those same parentheses. You said the GCF is just a single C, correct?
Yeah.
And what do I do with the GCF?
Divide.
Yeah, we divide. So we divide each term by our GCF. Now watch what happens. There's a 1 right here. So 8 divided by 1 is what?
8.
So where do we put that?
Somewhere. Oh, right next to
Inside the parentheses now, right?
Yup.
What is C squared divided by C?
C squared.
No, BC.
You see? Okay, that works too.
That is C squared divided by C. This is a 1. So what do we do when we divide?
Subtract.
Subtract them. And 2 minus 1 is?
1.
1. Yay. Bring down the what?
The plus the sign.
There you go. 7 divided by 1 is what?
7.
C divided by C is what?
C.
Seriously?
Shut up.
C divided by C is C?
What happened?
C divided by C is C?
C?
What's 4 divided by 4?
Oh, it's 1.
There you go.
I'm
So-
dumb.
Me being factored is right there. That's your answer. And that's how you do that. So use the parentheses, put the GCF on the outside, divide each term by the GCF, and then
Wow,
you
I'm retarded.
This is called factored form. All right. Great job.
No, it's not. I feel dumb. I still don't know what's going on.
All right, we'll do it again so you can see it, okay?
Okay.
So I'm going to use a different participant, Isaiah.
Hello, Mr. Harris.
How you do, sir?
Doing good.
So let's do number 9 together. So now, what do I do to this equation?
So we factor in this. You want to put the parentheses around it
Awesome.
and then put the parentheses under it.
Yes.
Now you want to find that greatest common factor.
Of what?
So 15 and 18.
And what would that be?
That'll be 3.
Awesome. And now?
All right, so here we go on divide.
Hold on. You did the numbers. What about the variables?
Oh, you're right. Variables, we can look at what can we pull out. So the other one has a 1 by it, so we can only pull out X1. That's it.
That's it. X to the first. That's the smallest power. Good. Now what do we do with that 3x?
We said we're gonna divide now. So we're gonna do, put the 3x under there. Now we're gonna divide the 15 by the 3. That's gonna be 5. And then X5 and X1 is gonna be X4.
Sorry about that. I got big hands. You messing me up.
I feel you, bro. Big can't struggle.
There we go. 3x. 3x. You said 5, and then x to the what?
It's gonna be x to the 4th power.
Good. Bring down the
Negative sign.
good.
We're gonna go ahead and divide that. That's gonna be 6.
Good.
And then and that's it, right?
That's it, because x divided by x is
It's gonna be a 1.
awesome. That's a great job. So this is the factor form. Now you're probably asking me, what in the world? Why are we doing these things? Let's just prove that we actually found the factor form of that. So let's put 3x, 5x to the 4th, minus 6. And let's say you didn't see all of this. And I just gave you this. And you would naturally just say, okay, I'm going to distribute. And with that distributing, goodness gracious. All right, let's go down here. See, I'm glad that it actually did that. So 5x to the 4th minus 6. If I gave you just that problem, you would distribute. And with you distributing, you would go here and here. And then 3 times 5 is what? 15.
15.
X times x to the 4th is what?
X to the 5th.
X to the 5th. And 3 times negative 6.
Negative 18.
And the x is
X.
correct.
That's how it goes.
Just that if I distribute, I get back what I started with. If I factor, so it goes in a circle. Here's distribute. If I divide this, I would get what?
You go in and get that same problem you got on the left.
Good. Factored form. So you see how they go, they're opposites of each other. It's like plus and minus. If I add 4 to a number and subtract 4 from a number, I get the same number, correct?
Uh-huh.
Yeah, I don't know why it keeps doing this, but it is what it is. We're good. Okay. So let's go to our next participant. Who's going to be our next participant? Let's just look down here, see what we have going on. Say hi to the masses. I got Jonathan Hazan. Jonathan,
Hello,
how you do, sir?
I'm good. How are you?
I'm doing great. I'm doing great. All right, let's ratchet this up just a notch, okay? So now, how many terms do you see in problem number 13? How many terms?
6.
How many
2.
terms do you see? You with me? Did you mute yourself? You didn't mute yourself. Jonathan, there you go. All right. Terms are separated by plus or minus signs, correct?
Yeah.
Therefore, I have one expression on the left, one expression on the right. So how many terms do I see?
4.
What number do you see that I just wrote?
2.
2. Because there's a left side and a right side of this plus sign, correct?
Yeah.
Yeah, good. All right, so now let's do a comparison. Do you see anything that is the same on the left side that is the same on the right side?
There's 2. There's 2 things that we can distribute.
Not asking you to distribute. I'm just saying, do you notice anything that is the same on the right side and the left side?
Oh, both sides have n+5 in parentheses.
Good. That is exactly what we're looking for, because the greatest common factor is something that I can pull out of from the left side and the right side. So my GCF in this problem is going to be what, Jonathan? It would be that n plus 5, correct?
Yeah.
Now, I told you to put parentheses around the whole equation, correct?
Mm-hmm.
And then put parentheses where?
On the bottom.
On the bottom. What did I tell you to put out to the left?
The greatest common factor.
Good. So let's do that. And the greatest common factor is n plus 5, correct?
Mm-hmm.
And then what did we do with the GCF?
We
We divide, correct?
yeah.
So the word factor means divide in your mind, okay? We're going to factor something out, and we're going to use division to do it. So if I divide something like 4 divided by 4, what's 4 divided by 4?
1.
1. So if I have an n plus 5, isn't that the same thing as just saying 1?
Yeah.
And isn't this n plus 5 divided by n plus 5?
Mm-hmm.
So now, what do I see that's left?
3m and 4.
What kind of 4?
Positive 4.
You see how that worked?
Mm-hmm.
So my answer is n plus 5 times 3m plus 4. Now I'm going to open this up real quick. Does everybody understand that?
Mm-hmm.
Mm-hmm.
So this is really about a visual. If I can recognize what's on the left side, what's on the right side, I can find out what the GCF is really, really quick. It doesn't always have to be a number and a variable. It can be an expression. Does that make sense?
Yeah.
Now,
Mhm.
right now, the only thing that we're doing pretty much is pulling out binomials. We're not really pulling out anything else besides a binomial, okay? The reason why it's crashing, I know on this computer, it doesn't have a whole lot of RAM, and it has to, it has Zoom going plus OneNote, 2 powerful programs, so it crashes, but it loads right back up. So just bear with me. So now, how many terms do y'all see on here?
2
2. There's 2 terms. What are terms separated by?
parentheses.
What
Oh,
are
the sign.
what kind of signs?
Addition,
Addition and
subtraction.
subtraction. Good. Awesome job. I'm glad that you're paying attention, Gabriel, unlike everybody else. So now, let's go here. Got my Marie. Yay, Marie, Marie. How you doing, Marie? Marie, don't act like you silent. I just heard you eating your breakfast. Marie. Such a shame. Such a shame. Where'd you go? You muted yourself again? Marie. Mute. There we go.
I've been talking to you the entire time.
Oh, I'm sorry. You know, technical malfunctions.
Right.
But here we go. What do you notice is the same on both?
We're still doing this.
Marie.
B minus 3 and B minus 3.
There you go. So that becomes your what?
Greatest common factor.
Awesome. And what do we do with this problem, problem number 14?
We have to factor it.
True. And how do I do that?
By putting A, B, and C.
Too far.
Too far?
Yeah, we're not factoring a quadratic. We're factoring the expression. So what you're going, A, B, and C is your quadratic. All right. So
Oh,
just real simple GCF and factoring. I can put it in parentheses, and then what do I do?
I don't know.
Make another set of parentheses, correct?
Mm-hmm.
What do I put out to the left side in front of it?
What are you gonna put out to the left of it?
Yep. Outside of this parenthesis, what am I going to put?
I don't know.
Your GCF, right?
So B minus, or yeah, that's a B. B minus 3.
Good. So what do we do with that B minus 3 now?
Move it.
The word factor means to what? If I said distribute, what would you do?
Factor.
If I said distribute, what would you do? What do the arrows mean?
Like put it. I know what you mean, but I don't know how to explain it.
I know. You would multiply and distributing. What's the opposite?
Yeah.
The opposite of multiplying is to
Oh, divide. I didn't hear that.
divide, right? So I get B minus 3, and I divide each term by that. So that means what happens to the B minus 3?
It cancels out.
So what's left?
16B.
I got 16B on this side. What's left on the right side?
The addition sign.
And what?
That I'm not sure of.
What's 4
0.
by 4?
4 divided by 4?
Yep.
0.
4 divided by 4.
1.
So what is B minus 3 divided by B minus 3?
Whoa. B minus 3 divided by 1.
1, correct?
Yeah.
Final answer is B minus 3 times
Plus 1.
16
Oh, well,
plus 1. Does that make sense?
yeah.
Okay. It's got to make sense because the factoring the quadratics relies on these principles, okay?
Okay.
All right. So there's one more deal. Now this one combines everything, okay? Nuvia, you there?
Yeah.
Awesome. All right. So this one, I'm going to do one for you. And then me and you're going to work one out together, okay?
Okay.
All right. Now, this one you get to make some decisions on because you got to know if it's going to be positive or negative. But we'll find those out pretty quick. So I'm going to do 15 and you're going to do 16, okay? And just follow along. The first thing I want to do, factor each polynomial by what? It says it, grouping. So if I'm going to group these things, I'm going to group them with parentheses. Now I have 2 of them, but remember, this right now, once I put the parentheses, doesn't that say 2x cubed plus 8x squared times? But I don't want to times it because that would change the problem. So I add this plus sign. This plus sign is very, very important. We're just adding these 2 things together as if we didn't add those parentheses, okay? So now this is what we're going to do, Nubia. We are going to restart this program, and then we're going to do the left side, and then we're going to do the right side, okay? So the left side says 2x cubed plus 8x squared. The right side says 3x plus 12. And we're just going to, once we factor them, we're going to add them together. Remember that addition sign, okay? So let's factor just this side. Remember what we did. We put this in parentheses. We made our other parentheses. And then we put our GCF out to the left. So what's the GCF of 2 and 8? Well, 2 goes into 8, and 2 goes into itself. So I know it's 2. Now I look for the lowest power. I have x and x. They're the same variable. 2 is the lowest power. So I know there's at least 2 x's on the left side too. So I can pull out 2x squared. Now, what do I do with it? Since this is my GCF, I take my GCF and I divide it into each term. Okay? So 2 divided by 2 is 1. X cubed divided by x squared is just an x. 3 minus 2 is x. 3 minus 2 is 1. So that's x to the first power plus 8 divided by 2 is 4. X squared divided by x squared is just that, 1. Okay? So I'm done on the left side. I repeat the same steps. Repeat the same steps on the right side. So here we go. Put it in parentheses. Drop down your parentheses. And now I figure out my GCF. I have a 3 and a 12. Well, 3 goes into 3 and 3 goes into 12. So 3 is the biggest number. Now I look at my x and I have no x over there. So I know that 3 is my GCF. And then I take my GCF and I divide into each term. 3 divided by 3 is 1, leaves me with x, plus 12 divided by 3 is 4. Remember this plus sign, plus. So now, if I look, here's one term, here's my other term. What do you see? That's exactly the same.
They both have x plus 4.
Awesome. So doesn't that become my new GCF? X plus 4. Remember the empty brackets, empty parentheses? And if this is my GCF, what do I do with my GCF? I divide each term by that GCF. So this cancels, this cancels, this cancels, this cancels. What's left? 2x squared plus
3.
3. So your final answer is x plus 4 times 2x squared plus 3. So let's look at this. What did I do? I took the left side, factored it by itself. Took the right side, factored it by itself. Kept the plus sign all the way through. Once I factored it by itself, I factored it again. So here's one factor. And then I did it again as a group. And I came out with my answer. And that's the reason why I factor by grouping makes your life easier, because trying to factor it all at once would be a little bit hard. Okay? All right, so let's do yours. 4n cubed plus 3n squared plus 4n plus 3. All righty. So what do I do if I'm factoring by grouping?
Parentheses first.
So I split it into 2. What can I forget?
The plus sign.
Good. Awesome. Now what do I do?
Rewrite it again, the parentheses. Your second pair of parentheses.
Okay, so you're splitting them up. Good. Good. Now what?
You find your GCF.
So the GCF of 4 and 3, is there one?
No.
No. What about n cubed and n squared?
No.
N cubed and n squared?
2.
So n squared, correct? Now what do I do with that? What does the word factored mean?
Distribute.
No.
Divide.
Divide. Good. Distributing means multiply. Factoring means divide. Everybody get that together. Remember, our 4 checklist items: PEMDAS, distribute, remove fractions, and factor. They're 2 different things. They do opposite things. All right. So yes, I'm going to divide. I'm going to divide by n squared, divide by n squared. So there's a 1 here. 4 divided by 1 is what?
4.
N cubed divided by n squared. 3 minus 2 is?
1.
1. So I have 1 n left. Plus 3 divided by 1 is?
3.
N squared divided by n squared.
1.
1. Good. So I'm done there. Bring down the what?
The plus sign.
Good. Now I do this by itself. 4n plus 3. Put it in parentheses. Drop down my parentheses. Is there any GCF for 4 and the 3?
Nope.
Is there an n on both sides?
No.
No. So there's nothing I can pull out, correct?
Mm-hmm.
So now what do you notice? And this is true for every single time you do a grouping in one of our problems. What do you notice?
4n plus 3.
There you go. So that becomes your what?
Your GCF.
Good. And what do we do with GCFs?
Divide.
Divide. So 4n plus 3. 4n plus 3. So now, what's left on the left side?
N squared.
N squared. Bring down the,
Plus.
what's 4n plus 3 divided by 4n plus 3? What is 5 divided by 5?
1.
So anything divided by itself is always what?
1.
1. Does that make sense?
Mm-hmm.
So your answer is 4n plus 3 times what?
N squared.
Keep going.
Plus 1.
Plus 1. Great job. Does that make sense?
Yeah.
All right. So I know that a lot of you, when I ask the question, does that make sense? It's a yes or no question. And all of you tend to say yes. And then all of you go back and go, I don't know what the hell I'm doing. Make sure you're looking at the videos. Go back through. There are some step-by-steps to make your life easier. So I want to make sure I cover in the time that we have allotted factoring. But this one's a little bit different for 16-2, okay? So find the zeros. Whenever they say find the zeros, I'm going to come over here and I'm going to demonstrate. We know that a quadratic is called a parabola, which makes a U shape. If we were on a graph, we would have a y-axis and we would have a x-axis. It crosses the x-axis 2 times there. So this is what on the y-axis? 0. So therefore, we call these points the zeros. And why is that? Why does that make sense? Well, think about your coordinate pair. X is going to be some number. Y will always be what? 0. It's what we call what? X-intercepts. X-intercepts are where what? The graph crosses the x-axis. So the reason why I'm giving you this information is so this makes sense. Find the zeros of each function. f of x is the same thing as saying what? Y. So y is equal to x minus 3 times x plus 5. Now we just said we're going to set y equal to what? 0. And because of the zero product property, anything multiplied by 0 will get me 0. So therefore, all I have to do is set each one of these equal to 0. So minus 5, x is equal to what? Negative 5. Plus 3, x is equal to 3. So watch what happens. Let's prove this. My answer right there is x is equal to a positive 3 and a negative 5. So I can have two different pairs. Over here, that would be negative 5, 0, 3, 0. All right. So now, let me prove that to you. Let's substitute in 3. So 0 is equal to 3 minus 3, 3 plus 5. 3 minus 3 is 0. This is 8. 0 times 8 is what? 0. Yes, it checks. 0 equals 5 minus 3, and then negative 5, that is, and negative 5 plus 5. Well, this is negative 8. This is 0. Negative 8 times 0 is still what? 0. And that is the reason why we call it the zeros of the function. It's going to help me graph later on. I'm not going to get into graphing right now. I just want to make sure it tied in. Like, why are we finding these things and why is that true? Okay, so let me come back up here. There we go. So now, talk to me. Does that make sense?
Yeah.
See,
Yeah, kind of.
I know this is the first time you're seeing it or at least having to deal with it. So there should be questions. The fact that you're all saying, yeah, I get it. Yeah. Not exactly sure about that.
This all just seems like numbers to me.
I hope.
yeah.
Well, here's the thing. You got to break it down. The book breaks it down into parts. I already gave you a sneak peek into where we're going. You're going to need to be able to graph parabolas. A parabola is a U shape. It could be going up or it could go down. But either way, on the y-axis, think about this. Now I'm really going far. There's 3 different scenarios that could happen with this parabola. The parabola could be above the x-axis, so it never crosses. So how many zeros would you get? None. It could touch in exactly one spot. So how many zeros would you get? 1. And that usually would be your vertex. Then you can have a parabola that does that. And how many times would it touch? 2. So it can't do it 3 times because it's a U. It won't turn back around and come back. But it could be none, it could be 1, or it could be 2. And what are we talking about? 2 what? 2 coordinate pairs, or 1 coordinate pair, or no coordinate pair. All right. So that's a sneak peek into where you're going, but you need to be able to do the math of that. So it says find the zeros. If I'm finding the zeros, I'm asking where is the x-intercept? That means that y is equal to what? 0. If y is equal to 0 and I have things being multiplied together, I can just set them equal to 0. Because once I do that, as you can see in the proof, I know that 0 times anything else, this could be 8x, y squared, doesn't matter. 0 times anything is going to make it 0. So I got a negative number times 0. I still get 0. Does that make sense?
Mm-hmm.
All right. So now the first one was quite simple. Let's do the other one. Oops, hit the wrong thing. Let's mute Jamie. There we go. All right. So now let's take 4. This is a quadratic. Therefore, we need to, 1, factor it. Why? Because then I get 2 different binomials. This f of x is the same thing as saying y. So here we go. Let's factor x squared minus 4x minus 5. What is a? A is equal to 1. B is equal to what? Negative 4. C is equal to what? Negative 5. How do I factor that? Take the absolute value of A times the absolute value of C. So I get 1 times 5, which is 5. Then I do a list. This is a list. Always start with what? 1. So I get 1 and 5, 2, 3, 4, and I'm back to 5. So there's only one list of factors for 5. Now, C is negative, B is negative. Therefore, I know that the bigger number has to be negative. The smaller number has to be positive. If you don't know what I'm talking about, when I look here, there you have to, 1, go back to the lesson. I gave a video of it. And there's a graphic organizer there that makes your life simple when C is negative or when C is positive, and if B is positive or B is negative. So here we go. We're going to add them up. I want them to equal B. B is equal to what? Negative 4. Well, negative 1 minus 5 is negative 4. Yay, it works. Sometimes it won't work, just so you know. So that's my 2 factors. So how do I write this? This is equal to, the first term is always x. The second term, well, it's plus 1. The next term is negative 5. And there we go. We have y equals x plus 1 times x minus 5. But I want to find the zeros. So I make y equal to 0. And now all I have to do is set these equal to 0. So x plus 1 is equal to 0. So just minus 1 minus 1. X equals negative 1. X minus 5 equals 0. Plus 5 plus 5. X equals positive 5. So my answer, negative 1 comma 0, because we just said y is equal to 1, correct? I mean 0. And then positive 5 comma 0. Notice these 2 points are where the parabola would cross the what? X axis. And that's called finding the zeros. So y has to be 0 when finding the zeros. Okay. Let's see. Disappeared on me. I don't have Marie and I don't have Aiden. Why is that? Interesting. Okay. Let's go here. Isaiah. You understand that? Isaiah. Isaiah. Isaiah's gone. All right.
How am I still muted?
Okay.
What?
He's back.
How was I muted? I was unmuted, but then I was still muted.
I don't know. All right. So let's do one of these, okay? Let's say that the number, I'm going to take you one more step now. All right. Let's do 11. All right. So 11, is that a trinomial?
No.
No. So we want to get everything on one side. How would I get everything on one side?
You could probably do subtract that x2 on both sides.
You mean this? It's a 3x.
I was on the other side, but you go like that.
All right. So there we go. Keep your a positive. So I get x squared minus 3x minus 40. Can't get away from that equals. So what would it be equal to?
It's gonna equal to 0.
Yeah, there you go. It's equal to 0. So your life is easy now. Let's factor this. A is equal to what in this problem?
0. Oh, it's a 1.
B is equal to what?
3. Negative 3.
Negative 3. C is equal to what?
Negative 40.
Good. So here we go. A times absolute value of A times absolute value of C. So what is that?
It's gonna be 1 times negative 40.
One absolute value. Absolute value makes it positive, correct?
All right, yeah. Okay.
So 1 times 40 is what?
40.
40. Let's do the list. Let go of my ego. So always start with 1. 1 times what?
40.
2 times what?
Be 20.
3, does it work?
No.
4?
Yeah, 4 times 10.
5?
5 times 8.
6?
No, that don't work.
7?
And then 7 times 5, but 5 is already there.
And
5.
and 8's already there, right?
Yep.
So I'm done. So here we go. I know that C is what? Negative. B is also negative. Therefore, the bigger numbers, and notice when I do my list, my bigger numbers are always on the right side. My smaller numbers are always on my left. This makes my life easy. Since C is negative and B is negative, my bigger numbers have to be what?
To be negative.
Negative. My smaller numbers have to be what?
Positive.
Now watch. A positive 1 times a negative 40 gets me to what?
Times, right? So that'll give you a negative 40 anyway.
Negative 40. So I multiply them together, that still works. But when I add them up, what do I get?
You're gonna get a negative 39.
Negative 39. Now, positive 2 times negative 20 gets you what?
That's gonna be a negative 18.
Hold on. I didn't say add them. I said
You said
multiply.
multiply.
2 times a negative 20.
It's gonna be negative 40.
Negative 40, which is my C. Now, 2 minus 20 is what you said, negative 18. What's 4 times negative 10?
Be negative 40.
Negative 40 again. Good. What's 4 minus 10?
That's gonna be a 4 minus. That's gonna be positive 6.
Negative 6.
Negative 6. My bad.
What is 5 times a negative 8?
Be negative 40.
Negative 40, which is my C. What's 5 minus 8?
And if I'm honest, is a negative 3.
Negative 3. Which one is equal to my B?
Equal to the B. That would be the 5 minus 8.
There you go. So positive 5 times a negative 8 gets me to my C, which is negative 40. But a positive 5 and a negative 8 get me to my negative 3, which is B. So I can rewrite this now. What goes in the first term always? X, correct?
Uh-huh.
And what goes into the second terms?
It'll be the 5 minus 8.
There you go. So I put a plus 5 here. What do I put in the other one?
Minus 8.
Minus 8. This was all equal to what?
0.
0. So now if I want to find the zeros, what do I do?
You would distribute them.
Nope. If I distribute, I'm going to get this back.
Oh, you're right.
I don't want to distribute. I already factored it. So what do I want to do? X plus 5 is equal to what?
Just put 0.
Good. That's this 0 right here. So subtract the 5, subtract the 5. X is equal to what?
That would be x equals -5.
Good. Now you're going to get two answers. X what?
X minus 8
Equals
0.
what do I do?
You're gonna do add 8 on both sides.
X is equal to what?
8.
So my two answers, X
Are.
just said was -5, comma what?
And comma 8. That's all.
No. What's Y always if I'm looking for the x-intercept?
0.
This one says 8, comma
0.
good. Does that make sense?
Yep.
All right. We're just doing a piece of it. We'll end up getting it to where you'll actually see the graph and everything else. But right now, you need to be able to factor and find the zeros. And once you find the zeros, you found a piece of your parabola. Does that make sense?
Uh-huh.
All right. All right, people, that's our time for today. Let me unmute y'all. Are there any questions that y'all have for me? Any questions? Any questions?
About the contacting. My name's on the contacted, so I just contact you by
Yeah,
email.
I have to contact you too.
Yes.
I already
Everybody
contacted you.
contact me by email.
Bye.
I'm
Okay, so we just email you, right?
Yes, email me.
What do we email you? Just hi?
You know, say I received the letter or I received notification that I was supposed to contact you.
Yeah, you emailed my mom. You should
Contact
emailed me.
Wait, so that means you emailed my dad. Dude, I'm not a bro. Oh my god, bro. You're kidding me, dog.
Well, you guys have fun. Bye, Mr. Harris.
Y'all have a great
Bye.
Whatever,
Have a
Mr.
great day.
Harris. Bye.
Have a good one, Mr. Harris.
Bye-bye. Have a good one. All righty. House, let's get moving. I will share my screen now.
How was your weekend, Mr. Harris?
Do we have weekends now? I think the COVID-19 just make it days. That's all.
No,
we are
not
doing.
to me.
You had a good
To
weekend?
me, yes. I thought today was gonna be Sunday.
That's the thing. Sunday, fun day, Monday, Tuesday, Wednesday, doesn't matter. They're all days. Just
I still go in my backyard and spray my brother with a trampoline any day. I mean, spray my brother. Ah, my phone almost fell. I almost died.
Oh, here we go. DeAndre yelling already.
Oh, whatever, Aiden. Deal with it.
Don't you guys miss me?
No,
Yeah.
not at all, actually.
we
I miss everybody.
everyone.
I'm so
I don't
lonely.
miss Aiden. He lives like down the street from me.
I'm lonely. Okay.
So here's the thing. If you know these people, y'all should be checking this website. A lot of you are just going to HRW and then
Why is my name already the first one that I see?
because you wouldn't naturally pick out your own name.
Wait,
But
what? Wait, why are they there? Why are the names there?
they just need to get in contact with me.
Okay.
I'm scared. Okay, I got you.
You
Mr.
can
Harris,
take
I'm
my
here.
name off
I'm in
of the list.
contact.
I just got in contact with you.
I know. That's good.
Hey.
So get in contact with me. But you should be checking this so y'all know what's going on down here.
Wait, is it bad?
Nothing's bad. Everything is positive. We're in COVID-19 and I want to make sure that you're alive.
Well, you hear my voice, so you can take my name off of that list.
Nope, that's not the contact I want. I want to email.
Then it's a bad contact.
Why?
It's a bad thing. You want to talk to us. with.
We
It
Whatever.
is
appreciate
11
y'all
o'clock in the
that.
morning. Why are we yelling?
Take it off of there, please?
Because that's the way people respond. Talking loud voices. So here we go. We got assignments. Everything's due.
Can you put everybody on mute, Mr. Harris?
Not yet. I'm just making sure that everybody understands what's going on in their deal. The quick calendar makes your life easy. So this is what should be happening this week. All right. This is what you should be doing. You do have a quiz. The quiz is already open. So they don't want me giving it on one day or 2 days. They want you to have the whole week. So every assignment for me will always be open on Sunday and end on Friday at midnight. Therefore, come Saturday and Sunday, for a portion of those days, there will be nothing, no assignments, anything else, and that's when I will grade. Because that's the only way I can figure out who's doing what, when they're doing it, and everything else. So that is that. Let's get a move on. Today,
Let's just hope it doesn't crash.
Mr. Harris, I'm gonna go into your classroom.
don't go in my classroom. Leave my stuff alone. Here we go. Is Brooke there with you?
No,
Okay.
she's gonna be here tomorrow. I'm gonna make sure she comes on the Zoom tomorrow.
Yeah, she didn't do any work this week, so
Makes sense.
just put her on blast. But here we go.